Hello, welcome to the session. In this session, I'll introduce you about the big data and the Hadoop. Today's agenda is like what is big data, what are the issues of the big data, and how the issues are solved or mitigated by the Hadoop system, Hadoop technology, and what are the features of Hadoop so that it is very popular nowadays, and a little bit of the Hadoop history we'll discuss one by one. So nowadays people are keep on talking about the big data. So what is big data? So in our traditional systems like database systems or our existing system, you can say that system are capable of handling like some GBs of data or max to max like up to TBs of the data. So beyond that, it creates a lot of problem. So nowadays there are a lot of different data sources. Like for example, you can take the social networking sites like Facebook, Twitter, Google Plus, and WhatsApp. All those things, they are keep on generating huge amount of the data in a daily basis, in an hourly basis, or even you can say in every moment they are producing huge amount of the data. So that data, it may be a TB, it may be a petabyte, it may be zettabyte, it may be exabyte. So the huge amount of data nowadays it is producing by the different data sources. This is social networking sites I'm talking about. So there are a lot of data sources like aviation sector. Huge sensor data are keep on generating in every second. If you take the example of the stock exchange, in every second they are producing huge amount of the data. So all the data, the big data, you can say all the data are keep on generating. So most of the data, like 80% of the data are unstructured data, and maybe 20% data are like structured data. So if you take the example of each and every companies, the 80% data they are producing are unstructured data, and the remaining 20 to 30% is structured data. So to define the big data, IBM is given some definition which includes like 4 V's. So the first V is like volume of the data. So volume in the sense from the different data sources, how much data are capturing, how much data are collecting from the different data sources, from the different data sources, and storing in the warehouse like any database system, RDBMS, or any system where we are stored. So the amount of the data we are collecting from the different data sources, that is called the volume of the data, and the velocity of the data, at what speed the data are keep on producing. So here, how much, at what speed or how fast the data are generating. Like example, 100 GB per second or 1 TB per second, TB per second, like this. So this is the velocity of the data, means at what speed it is generating from the different data sources. So every moment it is generating, and very fast, very high speed it is generating from the data sources. So that is called the velocity of the data. And the variety of the data. Variety of the data in the sense like it is a different type of datas. Like it may include like structured data, unstructured data, and semi-structured data. Semi-structured data. So the structured data in the sense like it has some predefined schema. So it is organized way of collecting the data called structured data. For example, like CSV format file, like Excel file, we can have here, for example, we can have the employee name, employee ID, and employee salary. And it is completely distinguished, very clearly mentioned the name of the employees, employee IDs, and the salary. So this type of data, we can say it is a structured data. It has a clear-cut information, very meaningful information we can have here. And unstructured data, for example, unstructured data like audio, video, etc. comes under unstructured data. And the semi-structured data comes under like XML file, JSON file. So semi-structured data in the sense like half of the data are organized and half of the data are not organized. That is called the semi-structured data. For example, here, like this is the XML file and JSON file. We can have, by seeing this file, we can have some information. We can easily find out the information, and few of them are not. So this is the example of semi-structured data. And the fourth V is like veracity of the data. What is veracity? Veracity in the sense like I have huge amount of the data. Like for example, I have 1 TB of data. From that 1 TB of data, for my business logic, I can utilize 100 GB of data. 100 GB of data, which is very, very meaningful for this problem statement. So that is called veracity, like extracting the valid information from the huge amount of the data which are very, very inconsistent. So that is called veracity of the data. So here, by combining huge or high volume, high velocity, high variety, high veracity, combined to say it is a big data. Say it is a big data. So nowadays lot of internet connected devices are keep on generating huge amount of the data. So it is very, very difficult to store as well as to process the data by using our traditional systems. So in big data, there are two problems arises. The issues of the big data, I keep on saying. What are the issues? Big issues. It produces two issues. Majorly two issues we can say. The big data issues. Like one is storage, storage, or the storing we can say. And the second one is processing. So in our traditional systems, we can store 1 TB of data, 5 TB of data, or 7 TB of data, or 100 TB of data we can say. It can be manageable, but still nowadays the data is so massive and so complex, like every second it produces TB of data, petabyte of data. So it is very, very difficult to store in a traditional single system. So that is one issue. And processing wise also, it is very, very difficult to process the huge amount of data in a single system and provide the meaningful information or business information or any analytics on the big data. It is very, very difficult. So just I want to compare with the traditional system. with the Hadoop, how Hadoop came into the picture, and it solved both the issues like storage wise issue as well as the processing wise issue. It, it has been mitigated by the Hadoop technology. So for example, this is my traditional system. Okay. In this traditional system, for example, it is the enterprise system. Okay. Enterprise system. Enterprise system. So it has some limitation of hardware. Maybe the computation power depends upon the processor. The second one is RAM. The third one is capacity of the disk. Capacity. Storage capacity. Okay. x86 processor, you can say. And it is a temporary RAM, temporary memory. Temp memory, which is the processing component, and this is the hard disk, where we can store the information or data, you can say. So this is RDBMS system, RDBMS, okay, RDBMS system. So it can handle like 1 TB of data, max to max 1 TB of data in storage wise it can handle, but still it is very difficult to process. So if I process some logic, if I have the huge amount of data like 500 GB, I want to process 500 GB of data, I want to process by using my business logic. So it will take long time. It may take like 1 day or 2 days or 1 week, sometimes more than that. So it is inefficient and it is incapable of giving the end result or output in a timely manner. So nowadays the business can't wait such a long time to get the decision, to get the output of a business logic. So nowadays the company which takes the proper decision in a timely manner, he is the leader of the market. He can capture the business, he can expand the business very quickly. So storage as well as the processing is a problem in the traditional systems. Somehow, some extent we can manage with the storage wise. Suppose you are, maybe if you have like working in a admin side, you can have like a SAN system, SAN storage. So we can give some space from the storage to the RDBMS. Suppose here the limitation is 500 GB disk size, or you can say 1 TB of the disk size of the local disk, you can say the RDBMS, which is attached with the component. So hard disk is attached to this RDBMS system, that is called 1 TB. But I want to keep the data beyond 1 TB, maybe 2 TB of data. So for that I have to attach that other disks, or I have to get the space from the SAN storage. But attaching disk is a problem. It may not support because every system has some limitations, hardware limitations. It is a vendor specific. So for storing the data, more data, I have to connect to the SAN, and has given like another 1 TB of data, 1 TB of LON. 1 TB of LON, or you can say the space. Okay. Or you can say space. So I can store another 1 TB of data. But while processing the system, I have a client machine, I want to process some data. Okay, I want to process some data which is present in the RDBMS system. So while processing, I have the logic in my local machine. Logic or client machine. Okay. So I have the logic here, and I want to process the data which is there in the RDBMS system. So while processing, my logic is in the client machine or in local machine, we can say, and my RDBMS system is there at the data center. It is in the remote location. So while processing, while executing my code, while executing the script in the client machine, in this local machine, the data needs to be transferred from the RDBMS system to the client machine. So it produces network congestion, or the latency will be more while transferring the data. Latency will be more, and it produces the network congestion. So it will take long time. As I stated before, that it take long time to process the data and to give the output to the business. But if you go ahead with so here what we concluded, it produces two problems. One is processing problem, another is storage problem. Storage is a problem. Storage and processing takes long time, very long time. So this can be mitigated by the Hadoop technology. So Hadoop works in a server architecture, master-slave architecture. Hadoop works in a master-slave architecture, and it's based on the DFS file system, distributed file system, or you can say it's a parallel processing. So one would be a master system. And the remaining systems are the slave machines. Slave machine. So slave 1 you can say, or you can say it's a data node. I'll say why we can say it is a data node. Slave 2 or data node 2, slave 3 or data node 3, slave 4 or data node 4. And this master machine we can say it is a name node. So it is connected physically with a network cable and to form the cluster. Okay, it is a single cluster. So what is cluster? The number of machines, multiple number of machines combined to form one single cluster, and this cluster is a group of machines which acts as a single system. So why we can say it is a name node? So these systems are, Hadoop systems are, it is open source systems. Hadoop software is open source, so we can say it is open source, and it is running above the Linux operating systems. It may be any flavor of the Linux. It may be Ubuntu, it may be Red Hat Linux, SUSE Linux, Mandriva, etc. So systems are interconnected with the cables, internet connected cables, and after that we have to install the operating systems in all the machines. In this machine configuration, it may be homogeneous or it may be heterogeneous. What does it mean? the configurations are different configurations. Here maybe hard disks are different. I mean, the hardware configuration, some system having 100 GB, or some systems having the capacity of 500 GB, some systems having like 1 TB. Same RAM wise also it is different than each other, it may be. And but operating system wise it should be a single flavor, single version operating system, so that would be the good combination. But if you, why? Because it is a commodity hardware. So this cluster Hadoop is supporting of the commodity hardwares. What does it mean? The commodity hardwares are those systems which is very low reliable systems. It is not enterprise systems. It is a very low cost systems. Even our desktops we can include in this cluster on the fly. In the running condition also we can add the systems to form the cluster. There is no problem. So if you compare with the traditional system with the Hadoop system, you can say that here I am using only single system, one RDBMS, but here I have like 5 systems. So it may be very costly. It looks like it may be very costly because it's 5 machines to form one single cluster. But here it is enterprise hardware. So this machine is very costly. But here the systems are very low cost hardware systems. So in the company level you can purchase and you can instruct to the vendors, like those who are manufacturing the systems, and give the some configuration specific, and you can lower your budget and to order the very low reliable and some standard. Definitely some standard would be there, some standardized system you have to buy and to form the cluster. So how it mitigates the storage as well as the processing issues which is raised in the traditional systems or legacy systems which cannot be handle the big data. But here how it can handle the big data in Hadoop. Here for example I have 100 GB of data, 100 MB of the data. For example, I'll take one file whose size is 100 MB. Okay, so I want to store this data into the Hadoop file system or in the Hadoop cluster, and I want to process the data to get some business meaningful information. So this is my client system. The client system also should have like Hadoop software. Client system. Okay, Hadoop client you can say. Hadoop client system. Okay. So I have the 100 MB of file. So Hadoop file system, what it will do is it will divide the input file into number of blocks. So how many number of blocks? The block, what is the block size here? In Hadoop, the block size is the default block size in Hadoop 1.x. Hadoop 1.x is 64 MB, and Hadoop 2.x the block size is 128 MB. So what is block size? Block size is nothing but the chunk of the data it can read or write at a single point of time. So that is called block. So if you take the example here in Hadoop 1.x, the block size is 64 MB. So my input file is divided into how many blocks? It will divide it into 64, so it will give approximately 2. So the first block would be B0 would be like 64, and B1 would be 36. I think so. 36, right? Yes, 36 MB. Okay. So now the file which is there in the client machine, I want to upload, I want to store in the Hadoop cluster. So it divides the Hadoop software or Hadoop file system, HDFS file system. It will divide it into number of blocks. So in this example, I have 100 GB of data, 100 MB of the data. So it divided into 2 blocks. Okay, 2 blocks. 2 blocks. The block 0 is 64 MB and block 1 is 36 MB. So the first point of contact is the master node. So we can say it is a name node. So why we can say it is a name node? Because in this system, name node is a daemon which makes the system as a master machine. So daemon in the sense it is a background running processes. So the name node daemon is running in this system to make the differentiate among the cluster. So it is called a master machine or name node. While the system is running, while the system having the name node daemon, we can say it is a name node or master machine. Like that, in the slave machines, data node is a daemon which is running in this machine. In all the slave machines, data node is a daemon. It is running in every systems. So it can make a data node. The slave node 1 is called data node 1, slave 2 or data node 2, slave 3 or data node 3, slave 4 or data node 4. So all these machines we can say it is a data node because data node daemon is running in the background. So to make the system as a data node. So now I have the file here n of 100 MB. It is divided into 2 blocks, block 0 having 64 MB and block 1 having 36 MB. So what it will do, even though it has the capacity, it has the capability to store the entire data. Okay, 100 MB data it can store here because my slave machine's capacity is, we can say 100 GB. Or we can have minimum 500 GB. Okay, we can take the example of 500 GB. Because nowadays our laptop having 500 GB. So why not the server? So every machine having 500 GB, 500 GB, 500 GB disk capacity. So one machine can store the entire data, but in Hadoop it is not like that. So Hadoop is a distributed file system, DFS. This file system makes the Hadoop cluster very efficient. Okay. So the block 0 will store in a data node 1. Okay, the block 0 is storing here. It may pick any machine. Okay, it doesn't mean that it will take the first machine it will store. Not like that. I'll tell why it will choose and which machine it will choose, why it will choose. There are a lot of concepts are there. So we'll discuss one by one in the next sessions probably. And the block 1 will be stored in the S3. It chooses, okay, the name node pick the 2 nodes, it choose the 2 nodes. So the second block will store in B1 here, okay. Now here lot of questions coming, okay. So if this node goes down, okay, if this node goes down, okay, this node goes down or something will happen, okay, it may not came up, it is down, for example, you can say it is a down. So can I get my data? No, I can't, because only I have one block out of my single file, so I cannot get the data. So how can I mitigate this issue? So there is a concept called replication factor. There is a concept called replication factor. Okay, replication factor. I will discuss about this replication factor, how did data write and read happens, how it is replication factor. The default replication factor is 3, so it can be configurable. Okay, so how to configure all those things I'll let you know. I'll explain you in my upcoming sessions. The replication factor is 3. So what does it mean? It means any block will be will have a replica of 3 copies. In a cluster, the block 0 will have 3 copies. Okay? This is the original copy, and it can have like 2 copies, and it should not be stored in a single machine. Multiple copies of the same block will not store in the same machine. For example, B0 is here, so probably the B0 will store again in this machine, B0. Okay. Because replication factor is 3, so 3 blocks of same block will be replicated. So here probably block 0. Okay, like same B1 is here, then the second block or B1 will be stored here, probably block B1 here and block B1. Okay. Now the same situation, if this node goes down, can I have my file? Yes, I have the file. Here B0 and B1 is there, so this is the complete file. Here B0 and B1 is there, the complete file. So I can retrieve, I can read my file without any issues. So this is the beauty of Hadoop file system. So it is a fault tolerant. Okay, it is a fault tolerant system. So there are a lot of concepts like how the data read write will happen, what is the block size, what is blocks, and what is the replication factor, and how it can communicate with each other. All those things will be, we'll discuss in the upcoming sessions. So here how Hadoop knows, this master machine knows that I'll pick this machine or this machine at this point of time. How it will choose? So it has, so what is the master machine? The definition is, the master machine is the machine which will handle, which will manage the cluster, which will manage the slave nodes. That is called a master machine, and it has the name node daemon running in the system to make the system as a master node or name node. And what are the slave nodes? Slave nodes are the machines which are storing the actual data. Okay, the actual data stores in these machines, in the slave machines. Here actual data stores. Master machine will not store any data. It will store only it will keep the information about the slave nodes and the data's information. So that is called a metadata. That is called metadata. What is metadata? Data about data. Data or information. About the data. Okay. So it has many information. I'll explain you very thoroughly what is metadata and how it is. Just for introduction, I'm telling you. So it has the only information, okay, and it has the it will get the heartbeat signal. It will get the heartbeat signal from every data node. So it will get the heartbeat signal. Okay, get the heartbeat signal from every machine in every 10 seconds. Every 10 seconds, all the slave nodes, all the slave machines will send the heartbeat signal to the master machine, stating that we are living, I am living, I am living. So this node will say I am living, or this node say I am working fine. So it will send the heartbeat signal in every 10 seconds. As well as it will send, all the slave nodes will send the block report in every 1 hour. I'll tell you what is block report and what is the information about the block report, why it is required. All those things I'll discuss in my upcoming sessions. So due to this heartbeat signal as well the block report, the master node knows which machine is working what, at what point of time this machine is capable of storing or processing any data or not, and health of the nodes can be reported to the master machine. So it has the information what percentage this machine is utilizing and how much percentage is left over, which machine is very free, which machine is very engaged. All the informations are reported to the master machine. And master machine has the metadata, like data about the data or information of the data, so that while reading the data, it will not search all the way, to the first machine to the last machine. It will not search one by one, it will take long time, but it has the information like metadata. We can say it is a metadata. So it will read the metadata file and it will give the guidance to the client that okay, the block 0 is present in the first machine, or block 1 is present in the second machine. It will give the guidance to the client, so that client can read the data from the slave machines. So what is metadata? Metadata in the sense it can keep the information like what is the size of the data, what is the block of the data, the permissions of the data, and many more information. So the complete information of the data is stored in the master machine's RAM. Okay, it is stored. The metadata is stored in the master machine's RAM. Okay, so metadata is stored in the master machine. So that way it is, it will store the data by utilizing the intercluster, by distributing the intercluster. So here parallelism is happening. So the first block in this machine, second block this machine, so on. While reading the data, while processing the data, same thing will happen. It will pick one node and second node or third node or any node where the block is present. So a single task in the traditional systems, the single task will be processed by a single machine and it will take long time. Here the same task is processed by multiple machines. So for example, here the block 0 is processing in the first machine, and block 1 is processing by the fourth machine. So block 0 of the first machine and block 1 of the fourth machine will process simultaneously, parallelly, and will give the result, give the information, give the status to the name node, and name node will give the output, the final output to the client. I'll tell you the internal how it is happening, how both blocks are combined, and who is doing that. Another master machine came into the picture and he'll do all the job processing. So that is called job tracker. So I'll discuss all those things in my upcoming sessions. So this is only the introduction session of big data as well as Hadoop. So as per our agenda, we have discussed what is big data and what are the issues like storage as well as the processing issues, and Hadoop. So what is Hadoop? We didn't discuss. So Hadoop is a framework so that allows for the distributed processing of the large data sets across the cluster of commodity hardwares. This is the cluster of commodity hardwares. Like this is a low reliable hardware, we can say. It is a very low cost hardware. So it is utilized in the Hadoop cluster. So Hadoop is a framework that has the ability to store and analyze data present in the different machines. And it is very cost effective, very less cost, because it consists of commodity hardwares. And for the processing, we can have the MapReduce program. Okay, the logic is the logic we can send to the different machines. So logic will send the data here. Data is not sending near to the logic. The logic, the program, the logic, the piece of the logic will send to the data node, near to the data node. So logic is not local. The data is local. So we can say it is a data locality. But in our traditional system, it is a code locality. Okay, the script or the code or script is in the local machine, and the data will be transferred from the from the RDBMS to the local machine, and it will process. It will take long time. But here the code, we are sending the code, the code or logic will send to the data node or near to the data where the data is present. So it is called code locality. So this is a framework in the sense, Hadoop is a framework in the sense, like in the framework up to 60 to 70% of work has been done by the developers who developed the hardware software, Hadoop software. They have done the fantastic job. Like they have almost 60 to 70% work has been done. And the remaining 30% work will be done by the developers as well as the admins. So admin will facilitate, the administrators will facilitate the infrastructure to the developers, and developer will develop the logic to extract the business meaningful information out of the big data. It may be a structured data, unstructured data, or clickstream data, or video file, audio file, and any type of data can be processed by the Hadoop, not by the Hadoop. Hadoop with a lot of ecosystems are there, like Pig, Hive, HBase, Flume, Scoop. Lot of ecosystems are there, and they all are for the different purposes. That we'll discuss in our further sessions. So what is Hadoop we came to know, and what are Hadoop features. So there are a lot of features. There are lot of Hadoop features. Yeah, it is written here. There are a lot of Hadoop features which can highlight, which due to which the Hadoop become very popular. Nowadays Hadoop is very popular, right? So due to the below features, like flexible. Okay, so it is very flexible. What does it mean? Means it can process, it can store, and it can process different data types. Like it may be a structured data, it may be unstructured data, it may be semi-structured data. What type of data it may be, it can have the ability, it can process as well as it can store the data very efficiently. So that is called the flexibility of the Hadoop feature. And easily scalable. So in our traditional systems, in our traditional system, it is very difficult to scalable. Okay, if I want to scale this machine, suppose I have 100 users right away, and 100 users are processing, they are processing and storing the data in this RDBMS. So it is running very smoothly. But when the customers are increases, the users like 100 to 200 or 500 customers are increased, so that time if I'll store and I'll process the data, this machine will give very strain. It is very difficult. It will give the performance issue. So what I'll do is I want to upgrade it. Okay, I want to scale it. So how can I scale it? So maybe I can increase my RAM capacity. I can put some extra slots are there in the motherboard of this machine. I can increase my RAM size, and I can put some extra hard disks in this machine. If it is not supporting, then I can get the hard disks or the space from the storage disk. I can enhance my capacity, as well as if I replace the motherboard with the hi-fi configuration of motherboard I can put here. I can make the system enhancing. So there is a limitation is there. It cannot go beyond certain limits. So I cannot extend the RAM capacity more than the compatible capacity, or more than beyond the limit. So this type of scaling, so what I did in the hardware way, I scaled some extent but not beyond that. So this type of scaling, we can say it is a vertical scaling. Okay, we can say it is a vertical scaling. Traditional systems follow the vertical scaling, but here what is our point? Easily scalable. So here my cluster is in the running condition. I want to, and I think, so I concluded that my system, my cluster needs some more capacity and more processing capacity as well to handle the situation, to process the big data. So on the fly, on the running condition, I can add how many systems I want. Okay, I can go ahead and I can add one more system. If it is required, I can go ahead, I can add one more system. So like this, unlimited number of systems I can add in this cluster. Okay, I can add how many servers, how many hardware, how many systems I can add on the fly in a running condition without disturbing to the Hadoop cluster. I can add more number of systems. So that is called easy scalable. So in Hadoop 1.x some limitations are there, but if you go ahead with Hadoop 2.x software, we can have, there is no limit. We can add 4,000 node cluster, 4,000 and above also we can add on the fly. So there is no restriction. So it is very, very easily scalable. So that feature also very, very popular. And fault tolerant. How it can be a fault tolerant? Fault tolerant in the sense, the faulty, it can be sustained. It can be, mitigate the issue. If one system goes down or one system having some issue, also I can have the information. Like here, if this system goes down, I can have the file information or block information in this system, because the replication factor is 3. So to replicate the data across the multiple machines, the same block having multiple copies. If I have the replication factor 3, I have the 3 copies of one block. If the replication factor is 5, I have the 5 copies of the same block across the cluster. So very, very fault tolerant system. So fault tolerance is very, very high. Faster data processing. So how can we say the data processing is very, very fast? Because in the traditional system, it is only one system is processing the data and it will take long time. But here in Hadoop, the same task can be processed, the same logic, with the help of the single logic, the data is processed in the different machines. So the processing time would be very, very less, because I'm getting the parallel processing. At the same time, this machine, this block is processed. At the same time, the second block is processed by the another system and combined to give the output to the master machine, and master machine will give the result to the end client. So here parallelism is happening, but here the only one machine is doing the same thing. But here it is doing, the multiple machines are doing the same tasks. So that is called faster data processing. Ecosystem is robust. What does it mean? The Hadoop system, Hadoop technology is supporting with the many the ecosystems. Like as I have stated, as I told you before, that there are a lot of ecosystems like Pig, Hive, HBase, Plume, Scoof, Spark. Many more ecosystems are there, which we can integrate in the Hadoop cluster, and each ecosystem having their different functionality. They are used for different purposes. So that is called ecosystem is very, very robust, and it is a cost effective. As I stated, as I told you, This Hadoop cluster consists of commodity hardwares, low reliable, low cost hardwares. So this is called cost effective. So these features, and many more features are there might have. So these features makes the Hadoop system very, very popular nowadays. And we can have, Hadoop history, how Hadoop came into the market, who has developed this Hadoop ecosystem, Hadoop as well as other ecosystems. So we'll discuss and we'll conclude the session for today. So in 2002, Dov Cutting and Mike Caprilla, two guys, they're doing the part-time job for a notch product, for a project. You can say it is a notch product or notch project. So the main intention was to develop the search engine. So you can say in 2002 Google search engine was very, very popular. So why they are developing the same search engine? Because Google search engine is a commercial one. If any company want to customize their search engine, and they need to pay for the Google if they are using the Google code. But they both, like Dov Cutting and Mike Caprilla, they wanted to develop the open source Google search engine, not Google's search engine. So they implemented in 2004, they have developed the search engine software project, and they have implemented in that 20 node cluster they have implemented. So 20 node cluster is not more efficient, because in nowadays worldwide people are keep on searching, so huge amount of request it will hit to the cluster and it will break down, it will crash the systems, because it is 20 node cluster, it cannot sustain lot of requests. So what they did, they have extended to 40 node cluster. But still it is not very, very efficient to handle the huge amount of requests. But they stopped here. They cannot extend beyond 40 node cluster. So luckily in 2005, luckily they got some document which says published by the Google, that white paper. So in Google white paper, the Google has mentioned how to store the data in a distributed fashion, in a distributed way. The DFS, Google Distributed File System, they have developed, and how to store the data and how to process the data by using the distributed file system and the MapRedis, Google MapRedis program, by which we can process in a single point of time with using the multiple systems. So they went through that document, and in the meantime 2006 Yahoo came into the picture. And Yahoo approached the two guys, Dov Cutting and Mike Caprilla, and Yahoo hired that two guys, and Yahoo instructed to work under him Yahoo provided the infrastructure as well as the team to work or to develop the software. So but previously they were developed for the search engine, but Yahoo instructed, don't work for the search engine, work for the big data, because Yahoo was also struggling that time with the big data. It was very, very difficult for Yahoo to analyze and to store the big data. That was a very, very big challenge for Yahoo at that particular time. So he has facilitated the infrastructure, and he has given the team member resources, everything he has provided. In 2008 they have developed the Hadoop software. Okay, Dov Cutting and Mike Caprilla, they have developed the Hadoop software, and it was very, very popular. And Yahoo, at a point of time, Yahoo contributed to the Apache Foundation. Contributed to Apache Foundation. So the team members and Dave Cutting and Mike Caprilla, they all are discussed. So what the name will give to this software. So they cannot convince to with each other. So one day what happened? Dove Cutting's kid was playing with a toy. That toy's name was elephant. That toy was like elephant toy, and his name was Hadoop. So he came with that name. Okay, why not? I'll give the software name as a Hadoop because it is also very big, the elephant, and the same thing like it is handling this. This software is handling the very big data, very massive data. So why not? I'll give the name as a Hadoop. So he came with the suggestion. He has given the suggestion to all the team members, and all the team members are agreed on that. They are convinced because Hadoop was not a trademark at that particular point of time, and there is no copyright violation as well. So that way they have given the software name as a Hadoop software, and it is a open source software, and it is contributed by Yahoo to the Apache Foundation. And this Hadoop software, the Hadoop framework, is complete written in Java, and it is a very open source, and it can be framed, it can be combined a single suite, and it can be given by the cloud era, Hortonworks, as well as Mapper. They all are providing support, as well as they have given the single suite, the same software. They are bundled and giving as a package to the different companies. So that is a commercial vendors for the Hadoop, we can say, like Hortonworks, Cloud Era, Mapper. Now IBM also coming into the picture, maybe IBM Hadoop. So they are doing their commercial one. So this Hadoop cluster supports the heterogeneous as well as the homogeneous, and it is a very the Hadoop software, the open source software, is very robust, and it can be utilized by many organizations nowadays. So the market capture is very good to analyze the big data, to extract the meaningful information, business logic, and the different the in-time decision. By using analytics, we can get very meaningful business information from the big data by utilizing the Hadoop technology. So that's all today's session. Thank you so much.